Hey everyone, and welcome back to this class, the NumPy stack in Python. In this lecture, I want to give you a small update on the syntax for converting a Pandas data frame into a NumPy array. In recent versions of Pandas, you may have noticed that a warning appears when you attempt to use the asMatrix function. Let's do an example. So let's start by importing Pandas and NumPy. Now let's create a data frame. Doesn't really matter what's in it. Now let's try using asMatrix to obtain a NumPy array. As you can see, it says asMatrix is deprecated and will be removed in a future version, and we should use .values instead. So let's try that. Awesome, it works as expected. Now I think this is actually a pretty good change because the function name asMatrix is confusing. We know that a NumPy array is not the same as a NumPy matrix, and so we'd expect a function named asMatrix to return a matrix rather than a NumPy array. But in fact, the array is more useful to us because that's what's normally used in machine learning. Matrices are rare. Using the actual matrix object is rare. I want to also take this opportunity to discuss something else related to this topic, which I think is very important. Specifically, it's very important if you are a beginner to programming or machine learning. Luckily, nobody so far has complained that asMatrix is quote-unquote out of date. However, I've seen people get scared about similar things in the past, such as when you're switching from Python 2 to Python 3. The central message is, if you are a beginner, try not to be afraid of change. Changes happen to libraries pretty much constantly. If you freak out every time, then you will be freaked out all the time, and that won't really be helpful to your longevity in this field. The important rule I want you to remember is learn the principles, not the syntax. So repeat after me. Learn the principles, not the syntax. Let's go over some quick examples of how this principle can be applied and where it's been useful for me in the past. One great example is Tensorflow. Tensorflow at one point, around 2017 to 2018, was releasing new versions pretty much every month. They would make changes that would break your old code. Now, if you look at this from a beginner perspective, then every time this happened, you would freak out and not know what to do. Of course, you're not going to just throw away all your old code and start over, having to relearn everything about TensorFlow. Instead, you learn the principles, not the syntax. So one boilerplate line that changed was tf.initialize all variables, which was changed to tf.globalVariablesInitializer. If you only learn the syntax, then you'd be very worried because the syntax you previously thought was correct is no longer correct. But if you learn the principles, then you'd be safe. You know that both of these are doing the same thing, some kind of variable initialization. Another great example is going from Python 2 to Python 3. Beginners always get very scared about this because some code which works in Python 2 no longer works in Python 3. But the differences are so trivial, it always surprises me when people have problems. As an example, consider a for loop using the xRange function in Python 2. We would use xRange because the range function returns a list, which is slow and unnecessary. In Python 3, xRange is removed and the range function takes its role. So if you're a beginner and you're too worried about the syntax, you'd get scared because xRange doesn't work anymore, and now you can't get your code running. If you learn the principles instead of the syntax, you realize, wait a minute, both of these are just for loops, and we want to use a generator rather than instantiate a list in memory. The principle is important, not the syntax. This leads us to our final and I think most important example, which is learning different computer programming languages. At this point, 90% of the code I write is in Python, but I would be very comfortable writing in at least a handful of other languages too, such as Ruby, JavaScript, C, C++, and Java. Well, how can that be? Did I have to sit down and learn each of these languages from scratch? Do I have to constantly practice them so that I don't forget how they work? The answer is no. I've saved myself a lot of time by understanding the principles of computer programming instead of trying to understand the syntax. The syntax between these languages is similar, but not equivalent, and so if you let tiny differences in syntax be a heavy burden, you will spend significantly more effort trying to learn different languages. As an example, here's how you would print out all the elements of an array in Python, C++, and Java. As you can see, the basic pattern is the same. The flow of code is the same. The only difference is minor syntactical details. But I hope you can see that once you learn one language, learning another, similar language would become easier, because you would hopefully learn to recognize the patterns that appear across all the languages you learned. And those patterns you see are the core principles. They are called principles because they are fundamental constants which are unchanging. By learning principles rather than simply memorizing syntax, you make yourself more resilient to minor changes. And as you've seen with Tensorflow and a few other libraries, change is to be expected in this new and rapidly growing field. A lot of the libraries we use in data science are version 0.1, version 0.5, alpha version, and so forth. So you can already tell that they are in a state where nothing is set in stone. Once you learn to recognize the principles, you'll have a much easier time learning new concepts and adapting to new versions, new libraries, and even new languages.